This chapter focuses on the measurement foundations of RETs. High quality measurement is of course key to any empirical investigation. In my view, if you have bad measures, you're doomed. You absolutely must get your measurement house in order to do high quality RETs. Glossing over measurement details is just bad science. Here are my goal and objectives for you in this chapter. First, I discuss issues of metrics and do so in the context of the classic Stevens framework of nominal, ordinal, interval, and ratio level measurement. I describe many misconceptions people have about metrics, such as that 5-point Likert rating scales are by definition ordinal in character, or that the properties of a metric are inherent to scales and not to the broader measurement context that is operating. I develop the implications of this narrow thinking in depth. Second, I present the classic distinctions between random and systematic measurement error, and I consider measure reliability in that context. Many researchers think that Cronbach's alpha is a good measure of reliability for multi-item scales, despite the fact that psychometricians have been arguing otherwise for years. I describe more modern methods that you should be using. Cronbach's alpha also is not a good measure of unidimensionality, contrary to what many people think. Third, I discuss issues of aggregation bias and the tendency for many researchers to routinely sum subscales from a measure into an overall total score and then analyze that total score. Does it really make sense for half of the field to be factor analyzing scales in order to identify distinct components of them that can behave differently, only to have the other half of the field ignore those distinctions and aggregate all the subscales together into one total score? Fourth, I present latent variable representations of measures based on traditional structural equation modeling. I show the strength of this approach when trying to adjust for both random and systematic measurement error when conducting program evaluations. However, these strengths of SEM are not an excuse for using poor measures. SEM is hard enough when you have high quality measures, and it only gets harder when you start with two strikes against you with poor measurement. I encourage you not to fall into this trap. Fifth, a common practice in some disciplines is to take a continuous measure and dichotomize or trichotomize it to make it more interpretable or workable. In general, this is a bad practice, and statisticians have argued against it for decades. I discourage it and discuss perspectives on the matter, including the many ways you can get misled through false dichotomization and false trichotomization. Sixth, there is some controversy in the field as to whether one should obtain baseline measures of outcomes and mediators or not in RCTs. I describe the controversy and I lay out the strengths and weaknesses of including such measures. Ultimately, I recommend obtaining them, but I also recognize there are contexts where you would not want to do so. Finally, I discuss issues surrounding the timing of measurement and decisions about when to take a measure. This involves a careful analysis of how long it takes for a cause to translate into an effect. Sometimes the time it takes is very short, virtually instantaneous. Other times, the time it takes is very long, taking several months or even years. The timing of measurement is highly dependent on such dynamics, and I provide you with perspectives for analyzing it. There are many other interesting topics I address besides these. I hope you find some useful nuggets of knowledge here. Thanks.